Hello and what's up to you all, pre-matriculants? It is a lovely Monday. It is our triple M day. You know what that means? It means Mindset's Maths Monday, and it is more maths that we're doing today from what you were doing at school. So I want to know from you guys, how was your maths at school? How was your teacher? Share with me on facebook.com/learnextra. Join our 78,000 Mindsetters that are 77,000, 75 actually. Actually, it's 77. Sorry, guys. It's Monday. Hey, I need to do my maths. That's why I need my maths. It is about 77,000 mindsetters. So we're aiming to get about 78,000 by the end of this week. So currently, we're sitting at 77,502. So, guys, you know what to do. Tell your friends to like our page. Share the page with everyone. Tell your classmates, your teachers to even like the page. Or else join us also on Twitter by following us at LearnExtra. Well, today we are having a show, of course, which is about maths. It's all about maths. Dina has joined us. Dina, how are you?
I'm very well and very excited for this afternoon because it's exam time. So grade 11s, we are doing algebra, and all the little algebra that we've done currently on CAPS, that's what we're doing this afternoon.
Nice one. And well, let me tell you, Mindsetters, talking about mathematics and algebra, what you can do is you can challenge yourself on the Nokia mobile mathematics app, whereby your code as grade 11s, it's 0JRN. 0JRN. I'll also post the link to the app on Facebook, so keep your eyes on our Facebook page, and also look at the test yourself link, whereby if you answer the questions correctly, all of them or most of them, you can stand a chance of winning this awesome Casio calculator. Dina, you know, it comes in handy when you're about to write your exams. They need it.
Always. That machine really operates as a result of what's going on in your own mind. So firstly, let's have the knowledge, and then we'll plug it into the calculator, and magic comes out of that.
And then you use it when you're told to use it. That's another thing I was saying earlier on. As much as you might be having your calculator, read, follow the instructions. If they say do not use your calculator, then don't. Right.
Why is it that they say don't use the calculator? Is because we want you to use other methods of being able to get the answer. So you can certainly use the machine to verify whether a half times a half is a quarter, but you have to show methods that don't utilize the mechanisms that the calculator is using. So that's really, we want to see your thinking that is not a programmable thinking, but that's comes from knowledge of mathematical rules, and that's really why that's there.
That's a very good tip and advice. Thank you so much for that.
Good.
Let's continue.
Good. Right, Algebra Revision grade 11s. Let's get to what we're doing this afternoon. Okay, so we're going to revise the topics that were covered in term 1. We did a lot of work on exponents. We worked with expressions as well as equations, using the laws of exponents, adding, subtracting, multiplying, dividing surds, and also solving simple equations involving surds. Then we'll look at completing of the square, and we'll also solve quadratic equations using factorization and the quadratic formula, and we'll also look at solving simultaneous equations. And can you believe in all this section there's about 100 marks there? And if you haven't written your grade 11 mid-year exam yet, well, you should stay with us and just go through this quick tips on how to really get to the grips with these few core issues of mathematics. Okay, we always have a challenge question. So grade 11s, let's see how you do on the challenge question. I find that the biggest section that is really very poorly handled is always exponential work. So I've given you an exponential expression to simplify, and let's see what you do with that. We'll come back to that a little later. Okay, then I'm really putting these up as a source, as a tool for any of you who might not have access to some notes that you can consolidate in. So it's all your exponential laws, all the laws around the powers, and then a note, a very important note, that the laws only apply when working with products and quotients. So we're going to find that when you're using your exponentials, we need to look at expressions that have got a product or a quotient in them, and that the laws do not operate on the sum and difference. So at the outset, it's very important to analyze what kind of expression you have. Don't just read it and then just jump into it thinking that you know where you're going. You must really analyze. Have I got products? Have I got quotients? Have I got a sum and difference? Because if I have a sum and difference, then what I usually use to help me out there is to first factorize. So we do need to be aware of that. Okay. Exponential equations. We are going to use this rule that if we have a to the x is equal to a to the m, then because the bases are the same, we are going to equate our exponents only. So that's the rule that says if two powers are the same, the exponents must be the same. And any equation that contains more than one term, we are always going to factorize. So notice I've already used the word factorize twice, because factorizing is a very powerful tool to help us divide when we have a large number of terms. If we are looking at an equation that contains a square root, we're going to isolate the square root and we're going to square both sides. And we'll see these in the examples that will follow. Then we're looking at quadratic equations, and obviously the most famous of all quadratic or all algebraic theorems is this one, that if the product of two factors is 0, then a is 0, b is 0, and that we have a quadratic formula. And at this stage, grade 11s, you will not be getting a formula sheet, so you really do need to memorize the quadratic formula. In grade 12, you will get one, but if you want to get really high marks in grade 11, you need to memorize it. So I've given you some tips. When an equation is not linear, then we're going to rewrite the equation in the form ax squared minus bx minus c is equal to 0. We're going to equate to 0 before solving, and you then follow the instruction, as Abraham pointed out earlier, follow the instructions if you are going to be using the formula or if you're going to use the completing of the square. And then finally, simultaneous equations, we're going to focus on firstly the linear equation. We're going to identify one of the variables, and I've said here, if possible, the variable with a coefficient of 1. So a coefficient of 1 helps to keep 1 away from fractions, so that's a tip. And then we're going to substitute the linear into the nonlinear equation. Okay, so that's how to do mathematics in 5 minutes. Let's look at some examples. And please do refer to those notes. They are very helpful when getting to answering some of these questions. Right, the first one, solve for x and leave your answers in simplified surd form. So the instruction is always very important. Simplified surd form where necessary. And we've got x minus 4 all squared is equal to k, and we have 3 scenarios. We're going to solve the equation x minus 4 squared is equal to 0. We're going to solve the equation, and we've left off something over here that's negative 9. Okay, so we don't have a pin now. Okay, it's negative 9. Right, so we now have one equation, x minus 4 squared is 0, x minus 4 squared is equal to negative 9, and x minus 4 is equal to 5. We're going to solve those 3 equations. Now, grade 11s, have a look at the nature of this equation. X minus 4 all squared is equal to 0, and we now have the quadratic, or a positive expression is equal to 0, and we want to know when will that be true. Do I have to multiply this out, or can I tell what the answer is from this form? Well, grade 11s, when an expression is written as in factors, remember that quadratic equations, if they're already factorized, we are halfway there to solving them. So if you really want to understand what it says here, this is x minus 4 is equal to 0, or x minus 4 is equal to 0. There are 2 factors and they're exactly the same. That's what makes this multiplied by that equal to that squared. So we really have already got the linear, so we're saying x is equal to 4. If this factor is the same as that factor, then x is 4 in both cases. So we don't really have to multiply out. Remember, if we just go back to this note here, I want to go back to that one. Okay, in solving quadratic equations where the polynomial can be factorized, we will make use of the following property. If we have the product of 2 factors is 0, then one of them is 0, the other one's 0. So we don't want to expand. And I find grade 11s battle with understanding when must you multiply out and when should you keep it factorized. Well, most times we want to keep things factored. Our last resort is to expand, because the moment you expand a polynomial in algebra, you are giving yourself so many more terms that usually with an expression that's got a quotient in it, it's going to be impossible to divide. So I would always encourage to keep things unmultiplied, unexpanded, if I want to call it that way. So keep them together, keep those factors together, and as a last resort, if you really have got no other way of being able to solve this, then maybe multiply. So for the time being, look for the product of factors is 0. Okay, so here was a classic example. We had the product of factors is 0, and notice it wasn't written in this form. It wasn't an x minus 4, so there weren't two distinct factors. Okay, this would be two distinct factors is equal to 0, and this would be the same factor multiplied by itself is 0, but in both cases it's 0. So grade 11s, don't be tempted to multiply. Ask yourself, what are you doing? I am solving for x. If I'm solving for x, I want the product of factors to be 0. Product to be 0, not the product to be another number, but the product must be 0. So here we have the product of two distinct factors, and here we have the product of two factors are exactly the same. So in both cases, we could say x equals 4. We don't even need to look at that. We could do it by inspection. We could say when is x minus 4 is equal to 0, that would be when x is 4. Now, let's keep looking at the next equation. What about x minus 4 all squared is equal to negative 9? So that's the second case. What value of x must I have that when I square that bracket, I'm going to get negative 9? And grade 11s, I'm sure you out there saying, that's impossible. I can't multiply something by itself and get a negative. So in other words, whatever bracket I have, if I square it, my result must be positive. So x minus 4 squared is always positive. It could be 0. We've noticed that it could be 0 up at the top there. So what we're saying is that this expression can never equal a negative number. And for those of you that have done functions, you will notice that my quadratic is x minus 4 all squared, and that it's never going to be a negative value. So if this is my x-axis, there's my negative 9, so my quadratic is never going to be negative. So the definition of a quadratic, or a square, should I say, the definition of a square is that this is always positive for all x in the real numbers. Doesn't matter what x you substitute in here, it's always going to be positive. So in this case, we would say that there's no solution. So we had a quadratic equation with one solution. It only had one. You could say it had the same one here, but it's really one. You've got a quadratic with no solution. And then we have x minus 4 all squared is equal to 5. And this would be this case. So we're now sitting with a perfect square is equal to 5. Now, there's no 0 on this side. Remember, a square needs, or quadratic needs a 0, so we don't have a 0. So we could multiply, but grade 11s, we could do something simpler. We could say, therefore, x minus 4 must equal to root 5, or x minus 4 is equal to negative root 5. So we take the square root on both sides, but because we've got a quadratic equation, we're going to get both positive and negative solutions. So x is equal to 4 plus root 5, or x is equal to 4 minus root 5. And in that case, we've got two irrational solutions. So we can get one solution with a quadratic equation, we can get no solutions, and we can get 2. So 2, 1, or 0. And for those of you who've looked at the nature of roots, you will have seen how we discuss those kind of roots depending on the value of delta. Okay, we're going to get started on this one. Solve for x and y, where 2 to the x is equal to 4y to the minus 3, and where x squared plus y squared is equal to 0. So we have one equation. This is my first equation. And we've got a second equation. And we want to find x's and y's so that if I substitute into the first one or the second one, I'm going to have a true statement. Okay. Now there's my quadratic. So I'll always look at my other equation to see if I can find out some help with it. And I notice that it's an exponential. So you've got 2 to the x is equal to 2 to the y minus 6. So I'm making the same base on both sides. Remember our exponential equation, we want same base on both sides. Therefore, x is equal to 2y minus 6. So that's really equation 1. And we're now going to take the coefficient of 1, which is x, and we're going to replace it in here. So wherever x is, we're going to say it's the same as 2y minus 6. We're going to square that. We're going to add on y squared, and we're going to get 20. Keep on multiplying out, so we get 4y squared minus 24y plus 36 plus y squared equals 20. And I think I'll get you to work that out during the break.
Thank you so much, Dina. And I must say the mindsetters are on fire because they're already giving us some questions. So guys, keep them coming on facebook.com/learnextra. We'll see you after the break. Welcome back, awesome grade 11s, and now I can see you guys are all active on the page and enjoying the show. Thank you so much, guys, and a big shout out to all of you guys. Just looking at the mindsetters that are on the page, we have I am Kensir Lamane saying hi AB, and there's Tim Belief saying I love the show, it's so helpful. Thank you so much. Mindset Learn Extra. Thank you so much, guys, and be on the page. But most importantly, download your notes because that's what we want you guys to do. Learn more and learn extra with us. And if you do download your notes and then do the test yourself questions, you stand a chance of winning this awesome Casio calculator. Talking about which, Dina, I think I should announce last week's winner.
Yes, that's cool.
Right, give me some drum roll, and the winner is Mihlali Matlengwana. Congratulations to you, Mihlali Matlengwana. Can you say that, Dina?
Oh, no.
All right.
I'll have to see it in writing. I'm a visual person.
I'll write it for you. Well, thank you guys for entering for the competition. You still have got a chance, so make sure that you do test yourself and also go to the Nokia mobile mathematics and do the algebra questions and see if you understand. Challenge one another, and let's see who's on the leading board. But back to you, Dina.
Right, grade 11s, there are 10 multiple choice questions on the challenge yourself section. What's it? Test yourself
Test yourself.
section. And I've selected 2 of each type. So there's 2 on exponents, 2 on quadratics, 2 on simultaneous equations. And it really, if you can do those 10, then you're going to get 100% in your exam. So go out there, try those questions. So we'll have another winner next week for a Casio.
Yes.
Great. Right, I left you with a simultaneous equation where we substituted the x value into the quadratic, and we got to that step. And during the break, were you able to find that x and y value? I'm hoping you were, because I've got the answer for you. If you tidy up the algebra and you work through it, you get a y value of 4/5 and an x value of negative 22/5, and you get a y value of 4 and an x value of 2. I'm hoping that you plowed your way through that algebra and were able to get to the end, because the big part about the simultaneous is the setting up of the 2 equations and the substitution. Once you've done that, then the rest of it just follows sequentially very, very easily. Okay, so that was a simultaneous. Let's see what's up next. Okay, grade 11s, what do you notice here? Solve for x, and the equation is the square root of x minus 2 is equal to 4 minus x, and we're going to be able to solve for x. All right, now you need to tell me, what do you notice? Okay, there's an expression, and it's got a square root over it. So we're just going to do some analysis. Most of you in class will have done things like this, and you'll have squared both sides and solved for it. But before we jump in, I want to just look at the definition of the various expressions, or when are these expressions definable, so to speak. So if I look at the square root of x minus 2, for this equation to exist, what must x be? Or if I phrase it differently, what can x not be? Okay, so the moment you're dealing with a square root of x minus 2, we are saying that if this equation has to exist in the real number system, then x minus 2 has to be positive. Because if x minus 2 is negative, then we're going to get the square root of, let's say, negative 5, and then that whole expression is non-real. So we want x minus 2 to be positive, so we want the x value to be greater than or equal to 2. So whatever x value we come to at the end, we've got to make sure that x is greater than 2. Okay, but at the same time, we also have this constraint on this side because we have a number line, a real number line that separates positives and negatives. And on this side, we get all the roots. So we would get root 2, and then we would get root 3, and we'd get 2, and we'd get root 5. But on this side of the number line, what would we get here? Negative root 2, negative root 3, negative 2. So, and this looks a little bit messy. Let's just tidy this up. So over here, we would get negative root 2. This one over here would be negative root 3. This one would be negative 2, etc. So a root is always defined on the real number system by the sign that is before it. So these are all positives, and these are all negatives on the side. Okay. So for this expression to exist, and remember x can be anything, but we are forcing this right-hand side because the sign has been defined on the left. Can you see the root is already been defined by what sits in front of it? That's a positive. So we're wanting our restriction on the right-hand side to be that 4 minus x must also be greater than or equal to 0. If there was a negative on the side, then we would want that side to also be negative. So now we have a 4 that is greater than or equal to x. So x is smaller than or equal to 4. So we are saying that whatever x value we find, once we found it, that it must lie between the set. And if I draw a little set notation, look what happens. I have to have values that are bigger than 2 and that are smaller than 4. And they could include 4 and they could include 2. So there is something special about square roots. Square roots are only defined if what's underneath them, if that expression that's underneath them is positive. Otherwise, we are going to define them in the non-real number system. And grade 11s, when you get beyond grade 12, we do non-real mathematics. And there is a whole Cartesian plane around non-real mathematics. So it exists. But at school level, we are dealing only with real numbers. So if you're solving for x at school, they don't tell you solve for x where x is a real number. They'll just say solve for x, and we assume that it's real. So we would want this equation to give us real values, which means if that is the case, we want x to be bigger than 2. If x is 3, for example, 3 minus 2 is 1, so that's good. If x is 4, 4 minus 2, that's good. If x is 5, 5 minus 2 is 3, so they're all positive, that's great. Only problem is we want it to be equal to a positive number. So if we had to make it 5, for example, 5 minus 2 is 3, so we would get root of 3. But then on this side, we would get 4 minus 5 is negative 1. So 5 is not a solution. I would like to get the same thing on both sides. Okay, so with that little discussion, let's now do what you usually do at school, which is to say, if I have isolated my square root, I can now square both sides, because a square root multiplied by itself is equal to its real value. So we're saying this. If I have square root of 4 times the square root of 4, that is the square root of 16, which gives me a rational 4. So if I take a surd and I multiply it by itself, I always get the rational version. I don't get the irrational 4. So I know that from there, if I go from there to there, then over here, if I'm squaring that square root, I must get just x minus 2. And that will now be equal to, now grade 11s, be very careful when you multiply a binomial. How many times my students put up their hand and they say they're not getting it, and we look deeply into what's going on in their work, and we found that they didn't multiply that binomial accurately. So accuracy, grade 11s, is paramount here. If we want to be the civil engineers and we want to be the architects of the future, then accuracy is important. Otherwise, people are going to be driving over bridges that are collapsing and buildings that are collapsing around us if we're not accurate with our measurements. So accuracy grade 11's binomial, I will suggest that you do this. I did this when I was at school, and it really, really helped me to just write it out and to do the always, the outers and the inners in a little bridge, so that I can see that I've got minus 4, and I've actually got minus 16, because this is the term ultimately that people forget. Minus 4 is minus 8, not minus 16, plus x squared. So we now have x minus 2 is equal to 16 minus 8x. Right, let's tidy up the algebra. We've got an x squared term. We've got a negative 8x minus 1, which is a minus 9. And we've got a 16 plus 2, that's a plus 18, is equal to 0. So we've got that quadratic. Let's solve for that one. I think that negative 6, negative 3 will get us there. Notice how I'm using the power of signs. My n sign means that each sign will be the same, either both negative or both positive, and then my middle sign tells me which one it should be. So negative 6, negative 3 is negative 9, but look at how I've checked that I verified the accuracy of that statement. So x is equal to 6 or x is equal to 3. Now, that's 6 and 3. Remember what we said earlier? This orange set over here tells me what values it could have, and it said it had to be smaller than 4. So we're saying that 6 is not valid, but 3 is valid. So let's go and test. This one is not applicable, so this one would be the only solution. Okay, so we're just making some recommendations about what will work and what won't work. So let's go back and see what x equals 6. Right, if x equals 6, watch what happens. We've got, let's do it in yellow. If x is 6, 6 minus 2 is 4. The square root of 4 is 2. So I get 2 on the left-hand side. If x is 6 on that side, look what we get. 4 minus 6 is negative 2. So I'm getting a positive 2 on the one side, I'm getting a negative 2, I'm getting a contradiction. That's why I set up for you these constraints, so you could see how we can define a root and then already at the outset tell which solutions are valid and which ones aren't. And then when we come here, if we had to test it, we'd be able to see that it doesn't work. So the other solution was 3. 3 minus 2 is 1. Square root of 1 is 1. And 4 minus 3 is 1. So we're getting 1 on both sides. So that's the only solution. Now, you wouldn't have to do that at the outset. You could have tested your solutions and said which ones are valid. But oftentimes, we forget to do that. We forget to test the suitability of that solution. And so that's why I like at the beginning to analyze. The more analysis you make at the beginning, the less chance there is of you not actually having tested your solutions. And so only 3 is the solution, and you can tidy it up by saying the solution set is x belongs to 1, the set with one element, x equals 3. Okay, so that would be just a test of, if I've got a square root, yes, I'm going to square both sides, but only after you have isolated the root. That's very important. Otherwise, you're going to sit with middle terms. When you multiply the square out, then make sure that you've got the outers and the inners. And I actually like to write just above it that that's negative 4x, so that my head isn't accumulating too much inside it, but it's more visual, and visually I can see, okay, that's negative 8, and that's plus x squared. And do that for yourself as a tip in accuracy. And then we solved it, and then remember to test the solutions. Okay, if you haven't done an analysis, then we need to always test the solutions to verify whether they're valid in the original, because we've changed the original equation. We've squared all those things, so we no longer know what the actual nature of the expressions in both of the left and the right-hand side are. Right, grade 11s, let's see what's up next. One of the mindsets that asked about completing the square. What's the difference between completing the square and complete the square? I would say you've got to complete the square whichever way you look at it. So it's actually the same thing. We want to find an expression that puts it into the x minus p all squared plus q setup. So that's what we're going to do with this one. Solve for x by completing the square and leave your answer in simplified surd form. So let's go through the rules of completing a square, grade 11s. X squared must have a coefficient of 1. So this x squared has got a coefficient of minus 2, so we're now going to divide by minus 2. So divide by negative 2. So if we do that, we get x squared, and we divide positive 12 by negative 2, we get negative 6. And we divide negative 8 by negative 2, and we get positive 4. And 0 divided by negative 2 is 0. So we've made the coefficient x squared. And then completing a square is a simple process where you take half the coefficient, half of negative 6, and you take the whole thing and you square it. Okay, so anything around it. So can you see we have the positive 4? We need to take that across and minus 4 because we only want to complete the square on the x squared term and the x. What must I add? What constant must I add so that I make that trinomial a perfect square? And we've said we take half of negative 6, that's negative 3, and if we square it, we're going to add 9. And we're going to add 9 to the side. What you do to the left, you do to the right. So we now get an x minus 3 squared. So for the mindset who asked about the completing of the square, what you're trying to do is to try and get a trinomial into a format that has got this binomial squared. That's where we want to get to. And that's equal to 9 minus 4 is 5. Right, so this is a division by negative 2. And then this is the completing of the square. And there we go. So now we landed up in a situation where we have this perfect square which looks exactly like the situation we had earlier where we've got a perfect square equals to a positive. Therefore, I can solve for that value. X minus 3 is equal to root 5, or x minus 3 is equal to minus root 5. And x then is equal to 3 plus or minus square root of 5. So they're irrationals. If your perfect square is not equal to a perfect square on the right-hand side, then your solutions are going to be irrational. So grade 11s, I hope that helped to just consolidate the completing of the square, which is, don't even attempt it. Don't even go there if you haven't made sure that the coefficient of x squared is 1. Because if that coefficient is not 1, then there's no way that the process of completing the square can take place. So first, coefficient of x squared is 1. Next, I take half of the coefficient of x and I add it to the expression on the left-hand side and to the expression on the right-hand side, to both sides of the equation. And ultimately, what I'm aiming towards is driving towards this trinomial that can become this perfect square. So it really is two main processes, and you shouldn't make it complicated at all. It should be coefficient of x squared is 1, and then we get the half the coefficient of x, and we square that, and we add it to both sides. And from there, we factorize, and we then solve for x. So that would be that one there. Okay, and I think we'll get to exponents maybe after the break. Or is there a question from the mindset?
I think we can take the questions later on. I think they need a break. Eh?
Okay, they've been thinking really hard.
I just think for them. Well, during this break, Mindsetters, you've got the challenge question for you to complete. And also send me some questions if you're struggling anyway. I'm here to help you guys. And also go through the Nokia mobile mathematics, and your code is 0RJN. 0RJN. I know that some of you have been saying the links are not working, some of the links. So guys, we are fixing them. So check them out on facebook.com/LearnExtra. All is well. See you after the break. Welcome back, Mindsetters. Now, some of you are saying that they're about to write their paper on Friday. Most of you are saying that don't panic, guys. Relax. That just make sure that you've practiced and you're rest assured that whatever that you have practiced, it's what you know, and you can apply what you know. It will never become a surprise. So you always be tested. You always be tested on what you've been taught. And sometimes I know the teachers can surprise you, but that surprise is within what you've been taught. Am I right, Dina?
Perfect. Abraham, for Minister of Education, he's really talking good sense to you. Listen to what he has to say.
Thank you. So don't panic, guys. Otherwise, send your questions through because we're here to help you. It's another thing struggling, but it's another thing struggling alone. So struggle, but not alone, because we're here with you, and hashtag walk with us. So guys, back to you, Dina.
Do you want to tell them about the links, the Google links are working?
Yes, the links are working, guys. And just because I'm a nice guy, I'm just going to repost the links again for you guys. So the links that are posted, they're working.
Awesome. Right, grade 11s. I want to quickly go back to one of the questions that the Mindsetters gave us, and then we will follow up with a challenge question, and we'll do another example. Abraham, have we got answers for the challenge question yet?
Yes, we do.
Oh, good. So we'll
Yeah.
see in a moment how many of you were able to get it out. Okay, great. So one of the Mindsetters asked, how do we know that x is smaller than 4? And that condition is coming from the fact that this 4 minus x, in order for this root to exist, this right-hand side has to be positive. So I'm going to talk to you in opposites. So let's just go down here and talk about it here. So if we have x minus 2 is equal to 4 minus x, because this sign over here is positive, we want what is happening here to also be positive. Okay? If I had negative root of x minus 2, then this 4 minus x, remember 4 minus x is a straight line. Okay, let's look at it differently. It's a straight line with a negative 1 as a gradient, and it's going through 4. So there's my straight line. So can you see that at 4, I have a 0, but anything bigger than 4 will give me y values that are negative. It makes sense, doesn't it? If x is 5, I get a negative 1. If x is 6, I get negatives. So anything bigger than 4 gives me negatives, but anything smaller than 4 gives me positive. So 3, for example, 4 minus 3 is positive, 4 minus 2 is positive, 4 minus 0 is positive. So all these make it positive. So I have a real good example of why a straight line is so useful. Any values that are bigger than 4 will give me negatives. Any values that are smaller than 4 will give me positive. So if I had to make this statement true, I want what's here, because this tells me it has to be negative, I would like everything on the right-hand side to be negative. And if it is going to be negative, then, or 0, then 4 must be, then x must be greater or equal to 4. So greater than 4, I'm going to get positive values. So two things. One, the sign of the root will determine what value I'm going to get on the right-hand side. So this defines for me, am I going to get a positive on that side, or am I going to get a negative on that side? So in this case, it's defined as positive. In this case, it's negative. So because it's an expression, because it's not a number, 4 minus x can both be negative and 4 minus x can be positive. Sometimes it's negative, sometimes it's positive. So this is a real insight into algebraic expressions and how they're defined and what kind of nature they have, whether they're positive or negative. And that's a very good question, because it's really a difficult thing to absorb and understand that expressions can be both positive and negative, and sometimes they're always positive and sometimes they're always negative. But the sign of that square root actually defines what it should be. Right, so as promised, let's go back to the challenge question and let's see how many of you got it right. So we needed to simplify. Tip number 1 for this afternoon was analyze if you're dealing with products and quotients or if you're dealing with sums and differences. And when I look at this fraction, my eyes are automatically drawn to this division line, and I look at the numerator and I see there are terms, and I look at the denominator and I see there are terms. So the biggest mistake, grade 11s, and hopefully have a look at your work and see if you did this, is that people will say that this goes in there and I'm left with 2. That's all they say. And so they're not observing the rules of, there are terms. I was almost going to say the rules of engagement, which really is, how do you engage with exponents? And because of those terms, that rule does not apply. When does that rule apply? If in the numerator I only had a product. So if I had 5 to the power of 2014 times 5 to the power of 2012 times 24, if it's only products, grade 11s, the rules of exponents exist. If I have terms, then those rules don't exist. So how or what do you use to get out of that situation, that predicament? Well, we are going to be very clever, and grade 11s, you should be shouting at me from your lounges. You should be saying, I know, I know, I know. We always, when we're in a sticky situation, we will factorize. Okay, so whenever we have terms, we will factorize before applying any laws. Okay, and that's why I made this the challenge question, because so many of you would have just, some of you may have just divided those two in there. And that division is prevented because there's an order of operation that says, please find the answer in the numerator and find the answer denominator and then divide. So it's back to maths as an order, and if it didn't have an order and we can't read the order, you and I and Abraham will all be getting different answers because we will be operating on our own rules and not on the rules that govern the order of mathematics. So let us factorize a little bit here. If we have 5 to the power of 2012 as a common factor, and in exponential language, your common factor has to be the base and the exponent. You can't just take out a base. You take out a unit as a common factor. So we've got 5 to the power of 2012. Can you see that I'm left with 5 squared? That if I multiply that by another 2 factors of 5, then I get 5 to the power of 2014. Okay, and I've taken that all out, so I'm left with minus 1. And I'm then left with minus 24. And in my denominator, I have a 5 to the 2012. Well, that doesn't really factorize, does it? Let's just see over here whether does 5 to the power of 2012 minus 1. Okay, so let's keep going. Let's just leave it because it's not really factorizing. Doesn't have any factors. That's all it is. Can't factorize. So when it can't factorize, let's just leave it there. Let's see what happens. Okay, so we now have in the numerator 5 to the power of 2012, and we've got this little 5 squared minus 1. Well, we know what that is. That's just 24. So we have that multiplied by 24, and we're subtracting 24. And we're now dividing it by 5 to the 2012 minus 1. Okay, there's still terms. Remember grade 11s, we said if there's still terms, we must factorize. I hope that that's what you're taking away into your exam this week or next week, whenever you write your exam, is that when we're stuck, we must factorize. So what is the common factor now? We have a 24 that we can take out. And what are we left with? We're left with this 5 to the power of 2012. And we have this minus 1 divided by 5 to the power of 2012 minus 1. So in the end, our answer is 24. Okay, 2 dozen. And who got that?
Yeah, let me check who got that. Wow, most of the mindsetters were saying no solution.
Oh, we
Okay,
need
but in the
to
meantime,
work on our exponent.
yeah. Okay, let me give you some questions, Dina,
Yes.
as I
let's do
check who got it right. The first question is from Sanele saying, when completing the square after making the coefficient of x to be 1, and then look at your binomials and squared them, I'm told that you should multiply what's not squared by that number you divided in your first step.
Just to repeat that.
When completing the square after making the coefficient of x to be 1,
1, yeah.
and then took your binomials and squared them, I am told that you should multiply what's not squared by that number you divided in your first step.
Okay, that's very convoluted and very, very confusing because the completing of the square is a basic process. And I want to go back to the notes that we did on that, which I think was over here. Let's see where our completing of the square is. Okay, here we go. We've made the coefficient of x squared 1. Okay, I don't have any binomials because the mindset is saying there are binomials there, and there's no binomials. There's what's left are 2 terms. One term has got an x squared in it, the other term has got an x term in it. And you're going to take those two terms and you're going to change them into a trinomial by adding a constant, by adding something. But that addition has to create a binomial squared. So if we take this x squared minus 6x, I don't want the 4 to interfere, so I'm getting rid of the 4. I don't let that affect me, so I take it over to the other side, and now I'm left with this white x squared minus 6x. Question is, how much must I add? And you must get a trinomial. So it's not a okay, maybe you're talking about the binomial x squared and x. From that binomial, you must add half the coefficient of x, and you must square it. Don't take x into it, otherwise it's going to be wrong. Take just the coefficient. So in this case, we took just negative 6, and we took half of it, and we squared it, so we got negative 3. And we took half of it, and we squared it, we got 9, so we added our 9 to both sides. And from that, you can then factorize. I hope that's clearer.
Okay, I hope that's clear for you, Sanele. Let's move on. Lucky says, how do I simplify exponents in which there is a plus sign between the bases?
It's Zanelli, hey?
Lucky.
Lucky. Okay, Lucky, you're very lucky to have us in the studio today talking about exactly that very question. Let's go here. Okay, now I've lost my exponential. Oh, it was a challenge question. Let's go back to the challenge question. Okay, what did I start saying? How did I begin this question? I asked you to analyze. And what Lucky is saying is, how do I deal with pluses and minuses in exponential format? And I said, if you take one thing away this afternoon, the power of factorizing. Excuse the pun. But factorizing is really a powerful tool whenever you're stuck. Firstly. Secondly, whenever you're dividing, when there's a big fraction line and you're dividing, you must remind yourselves that you need one term divided by one term. So Lucky, what's happening is that you don't have one term, and we would like to get to one term. So if there's any pluses or minuses, we need to get there. How do we get to one term? That fabulous tool that you learned about so long ago called factorizing. Okay, so hopefully, Lucky, that helps you and many other Lucky listeners too.
Okay, that was Lucky Ratau. I have another question from another Lucky Butelezi. Lucky Butelezi says, if you put a square root both sides, will your answer always be a positive or negative?
Let's just write down what Lucky's saying. Let's look at it. Okay, let's go there. Let's just see what Lucky's saying. Okay, Abraham, repeat that. If you put square root both sides. Okay, so I'm going to do this. X squared equals 4, and Lucky's saying if you square root both sides, okay.
Will your answer be a positive or negative?
Okay, a very common question and a very misunderstood concept. So let's give it a little bit of time. And that is that if x squared is 4, there is really a quadratic over here. It's hiding, but it's there. Watch where the quadratic is. X squared minus 4 equals 0. If a times b is 0, a is 0 or b is 0. So let's factorize. X minus 2, x plus 2 is equal to 0. So x is equal to 2 or x is equal to negative 2. Now, Lucky, what you're saying is if I take the square root of both sides, okay, you want to go from there and you want to go there. Does that answer your question? Okay, you've taken the root on both sides, but because hidden in that statement, that quadratic, is the possibility that we have two solutions. And yes, it is true, because if I square a number, what number must I square in order to give me 4? Well, I can square 2. But I could also square negative 2. Okay, so very misunderstood concept. If I've got a quadratic equation, then I'm going to always get two answers. And Lucky, for anybody else as well, if x squared is equal to 4, if you think you're not going to get those two solutions, why don't you go through the factorizing method, then you'll always get 2 solutions and you won't get it wrong. Okay, that's at grade 11 stage. At grade 12 stage, I'm expecting you to always be able to give 2 solutions. Okay, so yes, 2 solutions always when you find x.
All right, that's where we ended today. Thank you so much, Tina. Unfortunately, I know you enjoy. You could go for another hour again, swat the mindsetters, but unfortunately, thank you so much. We'll see you
Pleasure.
some other time.
See you soon.
Right, mindsetters, thank you for tuning in. We love you so much, and we're leaving you in peace.